This was a bird the size of a grizzly bear, with a head larger than that of a horse, and a beak that could crush bone. I find myself returning to the terror bird's skulls again and again. Recent studies have revealed a unique skull structure in Kelenken and other large terror birds, setting them apart. This terror bird skull type gave them a bite force and pecking power that was truly something to behold. It makes you wonder what kind of prey these giants were capable of taking down. The title of the largest terror bird is hotly debated, you know. Brontornis gives Kelenken a real run for its money. While slightly shorter at 9.2 feet, Brontornis was built like a feathered bulldozer. It could potentially weigh up to 880 pounds. Think about that. The heaviest carnivorous bird of all time. Brontornis has been the subject of scientific controversy, I must admit. Some paleontologists question whether it was truly a terror bird or even a carnivore. They cite similarities in its toe claws to those of herbivorous birds. But recent studies have identified features in Brontornis's vertebrae that are unique to terror birds, which lends weight to its classification as a member of this fearsome family. Whether Brontornis was a terror bird or not, its massive size would have made it a force to be reckoned with. Its weight likely made it slower than its more nimble cousins. But what it lacked in speed, it made up for in raw power. I can almost picture Brontornis as the tank of the terror bird world, capable of steamrolling over any prey. While the giant terror birds like Kelenken and Brontornis might have relied on their size and power, many of their relatives took a different approach. Speed, it seems, was just as important as size in the terror bird playbook. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches. Short thigh bones paired with elongated lower leg and foot bones. This adaptation is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 mph, faster than the fastest recorded human, Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry, while their imposing size and fearsome beaks often steal the spotlight. The true power of terror birds lay in their highly developed senses. Recent studies of terror bird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terror birds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But What really set terror bird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. As for their hearing, the inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. Imagine a terror bird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. To a casual observer, it might appear to be resting or even dozing. But in reality, every fiber of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleozoogeographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors that led to their demise. I find myself captivated by the story of the terror bird's downfall. It's easy to assume that these apex predators simply couldn't compete with the placental mammals arriving from North America. But a closer look at the fossil record reveals a more complex story. It seems most terror birds, along with many of their South American competitors, had already vanished long before the placental predators arrived in significant numbers. It makes you wonder what other factors were at play. The success of Titanis in North America also throws a wrench in the competition theory. This terror bird not only expanded its range northward, but coexisted with large canids and felines for millions of years. Clearly, at least some terror birds were more than capable of holding their own against mammalian predators. So, if competition wasn't the sole cause, what brought about their demise? As is often the case in paleontology, it likely involves a complex interplay of factors, with climate change perhaps playing a significant role. From the Oligocene to the Pliocene, Earth experienced a long-term cooling trend, culminating in a series of ice ages. This global cooling would have profoundly impacted the ecosystems that terror birds called home. As temperatures dropped and habitats changed, the lush forests that many terror bird species relied on would have gradually given way to more open grasslands. While some terror birds may have adapted to these new conditions, others would have struggled. The larger, more specialized species, in particular, might have found it difficult to find enough prey to sustain their massive bodies in these changing environments. Meanwhile, the influx of new competitors from North America, while perhaps not the primary cause of their extinction, would have added additional preys to already stressed populations. Despite these challenges, the terror birds proved remarkably resilient. Recent discoveries have pushed back the date of their extinction much further than previously thought, painting a picture of a group of animals that fought tooth and claw, or rather beak and talon, to survive in a changing world. For years, it was believed that terror birds had gone extinct around 1 million years ago. However, new fossil evidence has dramatically altered this timeline. Some smaller species of terror birds have now been dated to as recently as 96,000 years ago, a mere blink of an eye in geological terms. Even more tantalizing is the discovery of a set of fossils attributed to an unidentified terror bird species in a formation dated to just 18,000 years ago. If confirmed, this would mean that terror birds survived almost to the cusp of human arrival in South America, which occurred around 15,000 years ago. It makes me wonder, how close did humans come to encountering these feathered giants? What would such an encounter have been like? And, perhaps most tantalizingly, could there be any truth to the legends of giant birds that persist in the folklore of some South American cultures? While it's unlikely that humans ever directly interacted with terror birds, the possibility that our ancestors might have heard stories of these creatures passed down through generations is not entirely far-fetched. After all, other megafauna that coexisted with early humans, such as woolly mammoths and giant ground sloths, left lasting impressions on human culture and mythology. The near miss between humans and terror birds also serves as a poignant reminder of the incredible diversity of life that has existed on our planet. It's sobering to think that if the terror birds had managed to hang on for just a few thousand years longer, our understanding of the natural world might be very different today. Turning our attention to another group of dominant animals, the big cats. Today, the lion may be the king of the jungle, but the tiger stands out as the largest, most powerful, and most skilled of them all. However, there was one species in particular that stands above them all. The Ngandong tiger wasn't the only fearsome beast vying for dominance in its time. It faced stiff competition from other carnivores like the Smilodon, giant hyena, and dire wolves. The Smilodon, for example, is known for its long, slender canines that could reach up to 12 inches, capable of inflicting deep wounds on its prey. In contrast, the Ngandong tiger possessed more typical robust canines, similar to modern tigers, ideal for crushing bone and delivering powerful bites, though less specialized for deep punctures, which was not always effective considering the enormous size of prey then. Although, when it comes to the matter of size, it appears that they were evenly matched, at least when it came to the largest species of Smilodon. The Smilodon populator weighed between 220 and 436 kilos and stood 120 centimeter tall, which is not that far off from that of the Nyandong tiger. A less formidable rival for the Gandong tiger would have been the giant short-faced hyena, which stood about 90 to 100 centimeters at the shoulder and averaged 110 kilos in weight. However, a group of animals that the Gandong would not have dared to infiltrate were the dire wolves. Although they had smaller jaws and weighed way less than the Gandong tiger, they had a unique edge. They hunted in packs of more than 4 individuals. In contrast, as a solitary hunter, it would have been quite difficult for the Nyandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competition for apex predator status. However, that was not the only thing the Nyandong tiger had to worry about when defending the apex predator title, because around this time the early humans were notably prevalent in Southeast Asia, as over 80 individual remains have been found in that region today. So it's likely that they would have crossed paths with the Nyandong tiger. It is easy to say that such encounters would have been unfavorable for the early humans, because when it comes to size, they stood very little chance against such predators. But saying that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back against the Nyandong tiger, forcing the tigers back to the open woodlands, and allowing early humans to establish a foothold in the region. One thing about the open woodlands of Sunderland in the Pleistocene epoch is that it had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful despite the Nyandong's enormous size. For instance, stegodons were massive proboscideans closely related to elephants, with some species reaching immense sizes. Even smaller species of stegodons would have dwarfed the Gandong tiger. Stegodon donski, for instance, is estimated to have weighed around 12.7 tons. Their thick and tough skin would have protected them from bites or claws. Then Gandong tiger's best chance would be a scavenging opportunity or an attack on a vulnerable stegodon, like the young, injured, or isolated. Another example is the water buffalo, known as bubalis, which are renowned for their large size and formidable strength, with some species weighing over 1,000 kg and moving in packs. So it would have been quite hard to face a herd of water buffalo, as their massive size, strong horns, and collective defense would overpower the tiger. The Nyandong tiger's only chance against such a colossal opponent would be to exploit their limited agility and target vulnerable areas through a surprise or flank attack. However, the Nyandong tiger succeeded more with other herbivores like Rusa timorensis, Malayan tapir, giant rats, gibbons, and wild boars. Despite its many difficulties, the Gandong tiger still earned its place as one of the most impressive predators of all time. Since it hunted alone, its smart hunting skills and ability to target weaker prey, and even sometimes scavenge, shows us how adaptable and tough the beast was. This quality made it thrive for 1,000 years until the extreme climate shifts of the Pleistocene epoch. These included periods of intense cold, with vast ice sheets locking up water, leading to lower sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result of this, Sunderland was fragmented into smaller islands, leading to the isolated populations of Nandong tigers with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, scientists propose that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Nyandong tiger population. Other factors may have also contributed to their demise. But with limited fossil records, we are left with many unanswered questions. The saber-toothed cat. Even the name conjures up images of a prehistoric monarch, an undisputed ruler of the Ice Age. I remember the first time I saw a Smilodon skeleton in a museum. It wasn't just a big cat. It was something else. A predator redefined. Rewind the clock about 160 years. The story begins in Brazil with a discovery that initially baffled the scientific community. When the first Smilodon remains were unearthed, paleontologists didn't immediately recognize them as belonging to a cat. Gracilis, S. fatalis, and S. populator. If you were facing one, you probably wouldn't care which was about to make you lunch, but they did have differences. S. gracilis, the elder statesman, appeared in North America about 2.5 million years ago, descending from an older genus called Meganterion. S. fatalis arrived roughly a million years later, and S. populator made its grand entrance about 600,000 years after fatalis. S. gracilis, while not small, was the runt of the litter, about the same weight as a modern jaguar. S. fatalis was a step up, matching an African lion in size, but with extra muscle, weighing in at around 280 kilos. But S. populator dominated them all, pushing the boundaries of felid physiology, with the largest specimens weighing in at a jaw-dropping 470 kilos. That's about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to have significant size differences between males and females, a trait called low sexual dimorphism. So, male or female, you were in for equally big trouble. Smilodon wasn't just large, it was built like a prehistoric tank. Its heel bone was robust and elongated. Some paleontologists speculate these Ice Age acrobats could have outjumped modern lions, which can clear heights of 15 feet. Imagine a cat the size of a bear leaping over a one-story building. Using those muscular forelimbs and grappling hook claws, it would pin down its victim and sink its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But not everyone buys this gut-stabbing hypothesis. Many researchers favor a different scenario. Smilodon used its powerful build to quickly overpower its prey, then delivered a precise lethal bite to the throat, causing severe blood loss and suffocation. Adding fuel to this theory is the discovery that Smilodon could open its jaw to an incredible 120 degrees. That's almost twice as wide as a human can manage. With a gape like that, pretty much every neck in the Ice Age would have been fair game. But Smilodon wasn't just brawn and teeth. Brain scans suggest that these prehistoric predators had excellent coordination, sharp hearing, and top-notch vision. Their eye socket shape hints at binocular vision, giving them the depth perception needed to judge distances accurately, crucial for a predator that relied on ambush tactics. And if all that wasn't enough, they were fast too. Many Smilodon fossils show trauma to their sternums, the kind of injury you'd expect from high-speed collisions, suggesting that they were willing to risk a bruised chest in pursuit of their next meal. Smilodon's unique traits, along with its powerful weaponry, made it a versatile hunter capable of taking down a wide variety of megafaunal prey. The specific animals it targeted varied based on the region it called home. In North America, their prey included giant bison, camels, and even mastodons and Columbian mammoths. These cats were taking down creatures that dwarfed modern elephants. In South America, Smilodon's targets were equally impressive and diverse, including creatures like Toxodon, Litopterna, various species of Glyptodont, along with more familiar animals such as horses and camelids. Some evidence even suggests that Smilodon occasionally went after caimans. We know what Smilodon ate thanks to skeletal evidence such as tooth marks on bones, or Smilodon remains found alongside those of their prey. One big question that's still hotly debated is whether Smilodon was a lone hunter or a team player. Knowing whether Smilodon hunted in packs could tell us a lot about its social structure and what kind of prey it typically targeted. One of the strongest pieces of evidence supporting the idea that Smilodon lived socially comes from the La Brea tar pits in California. These California tar pits are a gold mine for paleontologists, preserving countless Ice Age animals. Most of the bones found in La Brea aren't from herbivores that got trapped, but from predators that got stuck trying to eat the trapped herbivores. Smilodon fossils are the second most common find in these pits, with over 166,000 bones attributed to it. This high number has led some scientists to suggest that Smilodon might have been a social animal. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group who then also got stuck. It's a grim thought, but it could explain why we find so many Smilodon remains in one place. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching, though in a prehistoric, slightly grim sense. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodon. I find it strangely touching to imagine a Smilodon with hip dysplasia somehow surviving to adulthood in the Ice Age. It speaks to a level of care that we often don't associate with prehistoric predators. Were these saber-toothed cats truly social creatures, like modern lions or wolves, caring for their injured? It's a heartwarming idea, picturing Smilodon families looking after their own. But not everyone agrees. Some researchers point to the isolated nature of Smilodon remains found outside predator traps, suggesting a more solitary lifestyle, much like many modern big cats. Regardless of whether Smilodon was a team player or a loner, There's no question it reigned at the top of the food chain. But that doesn't mean it didn't face rivals. The Ice Age was a time of giants, and Smilodon wasn't the only predator with an appetite for mammoth-sized meals. Two of Smilodon's biggest competitors were the American lion and the dire wolf. Now, while the dire wolves of Game of Thrones are impressive, the real ones, while formidable, weren't quite as monstrous. Isotope analysis reveals that they shared a very similar diet with Smilodon, meaning they often competed for the same prey. When it came to the American lion, it was probably a standoff. The American lion had size on its side, being one of the largest cats to ever exist. But Smilodon had those impressive canines, likely serving as an effective deterrent. Most likely, these two apex predators tried to avoid each other when possible, but conflicts could have gone either way. The dire wolf, on the other hand, seems to have often come out second best in confrontations with Smilodon. Evidence from La Brea suggests that dire wolves would frequently abandon their kills when a Smilodon showed up. I can picture it now. Those sabers on full display, convincing most predators that discretion was the better part of valor. But lions and wolves weren't the only competition Smilodon had to worry about. The Ice Age was also the time of the short-faced bear, a beast that could make even Smilodon look small by comparison. Some of these bears reached truly dinosaurian proportions, rivaling medium-sized sauropods in weight. However, these ursine giants were more omnivorous than Smilodon, which likely reduced direct competition. Plus, bears tend to be solitary creatures. So, if a group of Smilodons encountered one, the bear would likely have decided that this particular picnic basket wasn't worth the trouble. We've talked a lot about Smilodon's impressive hunting adaptations, but how on earth did it eat with those ridiculous teeth? After all, those saber-like fangs seem like they would have been quite the obstacle during feeding. Well, Smilodon had a solution. Unlike most predators that can chomp down from the front, Smilodon was equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. To eat, Smilodon would have turned its head to the side, using these carnassials to slice off manageable chunks of meat while its saber teeth stayed out of the way. If this eating style sounds familiar, that's because you might have seen it in action. Many modern cats and even other predators use a similar technique when tackling tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style accordingly. With its unique adaptations and hunting prowess, Smilodon carved out a vast empire for itself. The extinction of Smilodon marked the end of an era, the last of the saber-toothed cats worldwide. A lineage that dominated the planet for over 20 million years came to an end. Its legacy resonates in museums and in our imaginations, a reminder of the delicate balance between species and their environments. As we face our own period of rapid change, the lesson of Smilodon is clear. Survival requires adaptation. Most apex predators are limited by their environments. Lions rule the savanna, but are helpless in water. Great whites dominate the ocean, but can't survive on land. Even T-Rex was confined to dry ground. But then a discovery shattered the assumption that the greatest hunters were strictly terrestrial. Spinosaurus aegyptiacus was longer than a bus, with the skull of a crocodile and the body of an aquatic hunter. This was a nightmare that redefined what it meant to be an apex predator, rivaling and even surpassing T-Rex. The first thing that unsettles you about Spinosaurus is how perfectly wrong everything about it seems, yet how effective each bizarre feature proved to be. Take its skull, nearly 6 feet long, like something out of a nightmare. If you've ever stared into the eyes of a crocodile, you understand the fear of seeing a predator designed for aquatic ambush. Now, imagine that profile scaled up, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it moved through water with ease. Your entire lineage has adapted to recognize danger, the shadow of a pterosaur, the ripples of a crocodile, subtle current shifts. Every instinct is tuned to those watery warning signs. None of that mattered when Spinosaurus arrived. The attack began before you even realized you were being hunted. While you scanned for familiar threats, death approached from an angle you weren't prepared for: the shoreline. Those paddle feet weren't just for show. They propelled Spinosaurus through the water with surprising speed, allowing it to pursue prey through underwater mazes, where other large predators would become trapped. Unlike purely aquatic predators, or terrestrial ones limited to shoreline attacks, this nightmare adapted its hunting strategy in real time. Miss your target underwater? Simply rise to the surface and snatch prey from above. If prey took refuge in shallow water, those webbed feet provided perfect stability for wading attacks that no other large theropod could attempt. The hunting scenarios become even more terrifying when you consider Spinosaurus's intelligence. Crocodiles are clever hunters, but they operate on instinct. Spinosaurus possessed the problem-solving capabilities of a large theropod, the same tools that made its relatives effective pack hunters. Except this intelligence was applied to an environment where most prey had never faced anything remotely similar. Even more disturbing was how Spinosaurus turned the very act of drinking water into a death trap. Every animal in Cretaceous Africa needed to approach rivers and lakes. For millions of years, this had been a calculated risk. Stay alert, drink quickly, watch for crocodiles. Suddenly, the riverbank itself became unreliable. That submerged log might be a 50-foot predator. Those ripples might indicate the approach of something that could strike from below with the force of a freight train. The fossil evidence suggests Spinosaurus didn't just occasionally venture into water. It lived there. This wasn't a terrestrial predator that sometimes waded in for a quick meal. This was a creature so perfectly adapted to aquatic life that it spent most of its time submerged, transforming ancient waterways into hunting territories more dangerous than any terrestrial predator could create. In a world where survival depended on understanding threats, Spinosaurus represented something unprecedented. A predator that eliminated the fundamental distinction between land and water safety. It didn't just dominate two worlds, it merged them into a single, inescapable killing field. And we can't be talking about the perfect killing machine without mentioning its teeth. Conical, dagger-like, and built to clamp down on prey that thought the water would save them. Each one wasn't just for piercing. It was angled backward like barbed hooks, creating a living fish trap built on a terrifying principle: easy entry, impossible exit. But the teeth were just the beginning of Spinosaurus's sensory arsenal. Recent studies suggest this predator possessed pressure-sensitive organs along its snout, much like modern crocodiles, but far more specialized. In murky river water, where visibility dropped to mere inches, Spinosaurus could detect the faint press waves of swimming fish from remarkable distances. Prey animals that relied on hiding in dark, sediment-filled water were essentially sitting ducks against a hunter that tracked by feel rather than sight. Every movement in the water, a fish changing direction, a turtle surfacing for air, even the subtle current disturbance created by gills extracting oxygen, registered on Spinosaurus's pres sensors like sonar pings on a submarine's display. The creature could track multiple targets simultaneously, predict their movements, and position itself for killing strikes with mechanical precision. Those massive nostrils, positioned high on the skull like a crocodile's, allowed Spinosaurus to breathe while almost fully submerged, keeping most of its body hidden beneath the surface. But the true weapon wasn't smell. It was touch. Its snout was covered in a dense network of tiny sensory pits specialized for detecting press waves and subtle water disturbances. In murky rivers where visibility dropped to inches, this system worked like underwater radar. Every flick of a fish's tail, every ripple from a struggling lungfish, even the faintest shift in current. The sails served another, more practical purpose. When the beast needed to move through areas where full swimming wasn't possible, that massive dorsal structure acted like the keel of a boat, providing stability and control, even in water too shallow for other large predators to navigate. Spinosaurus remained a perfectly balanced killing machine. Even at 7 to 9 tons, it possessed the mass to overpower virtually any prey, yet remained streamlined enough to move through water with deadly grace. Modern great white sharks inspire fear because they embody millions of years of mastery in aquatic predation. But Spinosaurus had even longer to sharpen the same deadly craft, only with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. The result wasn't just a hunter of rivers and lakes. It was a 7-ton monster that transformed every waterway it entered into its personal killing field. I sometimes think about the press waves Spinosaurus must have created. Imagine the disorientation for its prey, those sudden shifts in the water as it moved. It could use the water itself as a weapon, its powerful arms and webbed feet generating currents. Its massive size creating press waves to stun smaller fish. The Kelenken formation reveals that this aquatic terror shared its territory with a deadly mix of predators, prey, and rivals. Giants like Charadontosaurus patrolled the inland areas, while Sarasuchus, the 40-foot supercroc, competed directly with Spinosaurus for aquatic hunting grounds. Mid-sized hunters such as Rugops cleaned up Spinosaurus leftovers, while swift predators like Deltadroius and Bahariosaurus carved out their place. Herbivores like Oranosaurus, Rebachiosaurus, and the colossal Paralititan somehow survived this gauntlet. The waters were filled with monstrous prey like entroprist, morsonia, chelanths, lepidotes, and lungfish. Every species lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. The last Spinosaurus died approximately 94 million years ago. Yet, the questions this creature raises about predation, dominance, and the very limits of survival continue to ripple through our scientific understanding. When we think of prehistoric apex predators, we often think of the Tyrannosaurus rex or the megalodon. But in North America's ancient past, there was a predator so extraordinary it could make today's largest wolves look like lapdogs. Today's grey wolf is the largest living canid, reaching weights of 65 kilograms. But rewind to the Miocene epoch 20 to 5 million years ago, and a new apex predator emerges. Epicon, a colossal predator so fearsome it could rival a lioness in size, and had jaws powerful enough to outmatch a grizzly bear. A dog that could eat a lion. Its name says it all. Epicyon, meaning more than a dog. The story of Epicon's discovery is one of paleontology's most intriguing progressions, from misidentification to revelation. Over 160 years ago, in the fossil-rich sediments of Nebraska, scientists unearthed the first fragments of what would later be recognized as the largest canid species ever to walk the Earth. The initial discovery consisted of a fragmented lower jaw, which, while obviously from a large carnivore, only hinted at the creature's true nature. Its wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. As more complete specimens emerged from North American fossil beds, a much more complex picture began to emerge. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. The skull. It was unlike anything I had ever seen. Those specialized in large premolars, that robust cranial structure. It looked more like a lion or hyena than any dog I knew. What was this creature? The key lay in those distinctive skull features, that powerful jaw. Adults routinely reached lengths of 2.4 meters, nearly 8 feet, rivaling a grizzly bear. They stood 90 centimeters, or 35 inches at the shoulder, about the height of a wild deer. These massive animals weighed between 125 and 170 kilograms, 275 to 375 pounds, heavier than modern leopards and comparable to large jaguars. Intriguingly, Epicyon haydeni exhibited significant size polymorphism, meaning there was considerable variation in size among individuals of the same species. Some individuals reached weights of around 170 kilograms, 370 pounds. Those giants would have matched medium-sized male lions in weight, making them the heaviest known canids ever to exist. Size aside, Epicyon's most remarkable feature was its bite. Biomechanical studies reveal that this ancient canid possessed one of the most powerful biting mechanisms ever seen in a mammalian carnivore. The enlarged premolars and strategically positioned canine teeth, closer to the jaw joint than in modern canids, created a highly efficient biting apparatus. The bite force may have exceeded 16,000 newtons, comparable to a large American alligator. This power was further enhanced by the positioning of its killing teeth. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips. The result was a bite that could easily pierce through thick hide, flesh, and even bone. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicyon used its formidable bite. These studies show distinctive patterns of wear consistent with both flesh slicing and bone crushing, suggesting a predator that could efficiently process every part of its prey. Fossil evidence indicates that Epicyon was an opportunistic predator capable of taking down a wide range of prey. Their remains have been found with ancient camels, pronghorns, horses, and peccaries. Most impressively, they seem to have hunted prehistoric rhinoceros species like Teleoceras, which could reach lengths of 4 meters, 13 feet, and weigh nearly 2 tons. It's thought that Epicyon may have employed different hunting strategies depending on prey size and availability. For smaller prey, they likely hunted alone or in pairs, using their speed and power to quickly overwhelm victims. But increasingly, evidence points to the possibility that they also engaged in pack hunting, particularly when targeting larger prey. Nearly all well-studied modern canids exhibit some degree of social behavior. The fossil record provides further support for this theory. Epicyon fossils are... The bones of Epicyon are among the most abundant carnivore remains we find in North American deposits. It's a pattern that makes me think of social predators, not solitary hunters. This abundance suggests something crucial. They maintained stable populations across their range, something we usually see in species that hunt in packs. I've spent years pondering what made them so successful. Epicyon's physical construction offers even more clues about their hunting behavior. Compared to most canids, both modern and extinct, they possessed a more robust skeletal structure with heavier bones. While this build might have limited their agility and endurance compared to modern wolves, it would have been advantageous in close-quarters combat with large prey. Recent studies suggest they were built for powerful, explosive movements rather than long-distance pursuit. It seems they relied on ambush tactics or short, high-speed chases, not the endurance hunting we see in modern wolves. Pack hunting would have been particularly advantageous here, allowing groups to surround and overwhelm prey that might have otherwise escaped a solitary hunter. But one of Epicyon's most remarkable adaptations was its ability to process and digest bone, a trait that truly set it apart. Their specialized premolars and thickened molars, with their short, pyramid-like shape and wide bases, closely resembled those of modern hyenas. It's a fascinating example of unrelated species developing similar adaptations to exploit the same ecological niche. Recent analysis of fossilized feces associated with Epicyon has revealed high concentrations of processed bone material, confirming this bone-crushing behavior. This adaptation would have provided several advantages. First, it allowed them to extract maximum nutrition from their kills by accessing bone marrow. Second, it potentially reduced competition with other predators by allowing them to utilize parts of carcasses that others couldn't process. The ability to process bone would have been particularly valuable during periods of scarcity. The Miocene epoch was characterized by significant climate fluctuations. During times when prey was scarce, the ability to fully utilize every part of a carcass, including the bones, would have provided a crucial survival advantage. The success of Epicyon is evident in its widespread distribution across North America during the Miocene. Fossil remains have been discovered in more than 10 different US states and parts of southern Canada, indicating a remarkable ability to adapt to various environments. Recent paleo-environmental studies have shown that these ancient predators thrived in a diverse array of habitats, from woodlands and savannas to grasslands and wetlands. I find it particularly interesting that we've discovered Epicyon remains in cave systems and edge environments, areas where different habitat types intersect. These findings suggest that Epicyon was not only adaptable, but potentially strategic in its habitat selection, preferring areas that provided both hunting opportunities and shelter. Their ability to process a variety of foods likely contributed to this ecological flexibility. While primarily carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of Epicyon from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction, but this has largely been discounted. Many of the large cats that would have competed with Epicyon, such as the famous Smilodon, didn't appear in North America until millions of years after Epicyon's disappearance. Current evidence points to climate change as the primary driver of Epicyon's extinction. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. Paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicyon's specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantageous as prey species became faster and more adapted to open environments, unlike their more generalized relatives, which gave rise to modern wolves and other canids. Epicyon's extreme specializations may have limited its ability to cope with these changing conditions. In the dying days of the Cretaceous period, the world was stalked by colossal predators like Tyrannosaurus rex, and creatures such as Triceratops and hadrosaurs often bore the savage scars of T-Rex attacks. Yet, amid this world of relentless aggression, one creature's fossils remain curiously unmarked by such ferocious battles. It wasn't the tallest, fastest, or most fearsome predator, but with a body armored like a tank and a tail capable of shattering bones, this creature defied the rules of survival. This was Ankylosaurus, nature's ultimate fortress. The story of this extraordinary creature began in the early 20th century, when paleontologists working in Montana's Hell Creek Formation uncovered a collection of unusual fossils. These weren't the typical bones they were accustomed to finding. Instead, they discovered an assortment. The first time I saw the scattered bones, the bizarre armor plates, the strange teeth, I knew we were the story of dinosaur defense. It was clear even then. This find would later be identified as the holotype specimen of Ankylosaurus magniventris, and it presented such a unique combination of features that it demanded its own taxonomic family. The name itself tells part of the story. Ankylosaurus meaning fuse lizard, a reference to its remarkably fortified skeleton, while magniventris translates to great belly, highlighting its distinctively broad midsection. The discovery of Ankylosaurus magniventris wasn't just a milestone for paleontology. It opened a window into the intricate design of one of nature's most formidable creatures. Back in 1906, Barnum Brown of the American Museum of Natural History led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, Brown unearthed an assortment of fossils that perplexed him at first glance. These were not the slender, elongated bones of theropods, nor the broad frills of ceratopsians. Instead, Brown had uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that hinted at a heavily armored animal. Early interpretations of these fossils were cautious. Brown initially speculated that the bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's physical characteristics. But among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered, with adults reaching lengths between 5.4 to 10 meters, or 17 to 33 feet, and standing about 1.7 meters at the hip. More impressively, these titans weighed between 5 and 8 tons, surpassing even the famously robust Triceratops in mass, and rivaling the earlier aquatic predator Spinosaurus. One might wonder how a relatively low-slung animal could pack such impressive weight into its frame. The answer lies in its extraordinary construction. Imagine a biological tank, meticulously designed for strength and survival. The Ankylosaurus's skeleton was built unlike any other dinosaurs, with dense, compressed bones forming a sturdy foundation for what would become one of nature's most sophisticated armor systems. Recent studies of its bone structure have revealed something fascinating. The bones themselves were uniquely reinforced with internal struts and buttresses, similar to the architectural principles used in modern building construction. This internal reinforcement provided an additional layer of protection beyond just the external armor, making every part of the animal resistant to crushing forces. The Ankylosaurus's skull alone is a marvel of design and intricate functionality. Shaped like a broad triangle, it was designed to withstand immense press. The hollow structure created a dome-like formation that distributed impact forces more effectively than solid plates would have, similar to how modern motorcycle helmets use their curved design to protect riders. This adaptation made the armor particularly effective. Imagine facing a T-Rex, not with claws or speed, but with a bone-crushing club at the end of your tail. That was the reality for Ankylosaurus. Its hunting strategy relied heavily on delivering powerful bone-crushing bites. But the Ankylosaurus had a secret weapon. Beneath its armored plates was a network of collagen fibers that puts modern protective materials to shame. These fibers, significantly thicker than those in modern armored animals like crocodiles and armadillos, created a natural composite material similar to modern fiber-reinforced plastics. Recent biomechanical studies have shown that this combination of hard plates and flexible fibers could absorb and dissipate energy from impacts in ways that purely rigid armor couldn't match. In fact, when subjected to simulated impact tests, reconstructions of Ankylosaurus armor proved capable of withstanding forces that would have seriously injured or killed most other dinosaurs. But perhaps the most fascinating aspect of the Ankylosaurus's defensive arsenal was its legendary tail club. This wasn't just a simple bony growth, it was a precisely engineered weapon system that represented one of nature's most effective deterrents against predation. Ankylosaurus thrived in the rich and dynamic ecosystems of late Cretaceous North America, particularly in regions that would later become known as the Hell Creek Formation. This area was a mosaic of environments, ranging from subtropical forests to open floodplains teeming with diverse flora and fauna. Fossilized plant remains suggest Ankylosaurus inhabited regions with abundant low-growing vegetation, which suited its low-slung, ground-grazing body. The climate of the late Cretaceous was warmer and more humid than today, which supported lush forests dominated by conifers, cycads, and ferns. Ankylosaurus likely played a role in shaping this ecosystem, though not as extensively as herding dinosaurs like hadrosaurs. Instead, its selective feeding habits might have influenced plant growth patterns in localized areas. The association of Ankylosaurus fossils with specific types of vegetation has led researchers to hypothesize that they may have helped disperse seeds, inadvertently promoting plant diversity. Seasonal changes would have impacted the behavior of Ankylosaurus. Fossil evidence indicates that some regions experienced dry and wet seasons, influencing the availability of food resources. Ankylosaurus may have adapted by modifying its diet or undertaking small-scale migrations to follow vegetation growth. The robust construction of its body, coupled with its ability to consume tough plant material, would have allowed it to survive in less than ideal conditions. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its presence in these environments exemplifies. I sometimes think about the marvel of Ankylosaurus, a finely balanced herbivore in a complex food web. Its adaptations always struck me as remarkable. That broad, low-slung muzzle, those simple ridge teeth, perfect for stripping ferns, cycads, and horsetails. Unlike some of its plant-eating cousins, Ankylosaurus didn't have elaborate dental batteries. Instead, it relied on powerful jaw muscles to break down tough vegetation before swallowing. And recent studies have revealed something surprising: a degree of dietary flexibility I wouldn't have expected. While it primarily ate vegetation, It may have occasionally supplemented its diet with protein-rich fungi or small invertebrates. It's a behavior not uncommon among modern herbivores, like tortoises and iguanas, which sometimes seek out extra protein. To process all that fibrous plant material, Ankylosaurus likely had a large, complex gut. Fossilized droppings from similar species suggest the presence of symbiotic gut bacteria, which would have been essential for breaking down cellulose. This process would have produced energy-rich byproducts, allowing Ankylosaurus to maintain its massive size. Its broad midsection, I believe, was a specialized design to house that extensive digestive system. All that volume would have provided ample space for fermentation and nutrient absorption, ensuring it could thrive on a relatively low-calorie diet. This, combined with its sturdy build and slow metabolism, likely made Ankylosaurus an efficient grazer, perfectly suited to its environment. But it wasn't just its digestive system that was finely tuned. Its sensory capabilities were just as remarkable. Its sense of smell in particular was highly developed. It would have been vital for locating food, avoiding predators, and perhaps even detecting mates. Fossil evidence reveals that the olfactory bulbs in its brain were unusually large for an herbivorous dinosaur, suggesting its sense of smell was comparable to, or even superior to, many modern reptiles and mammals. Advanced imaging techniques have revealed intricate nasal passages in Ankylosaurus skulls. These passages likely played a dual role, enhancing its olfactory capabilities and aiding in thermoregulation. The convoluted structure, with its larger surface area, may have allowed Ankylosaurus to cool or warm incoming air, helping it adapt to the varied climates of the late Cretaceous period. Vision and hearing also likely contributed to its survival. While its eyes were relatively small, their placement on the sides of its skull would have provided a wide field of view, allowing it to detect predators approaching from almost any direction. This peripheral vision, combined with its heightened sense of smell, would have made it difficult for ambush predators like Tyrannosaurus rex to catch it off guard. Though direct evidence for its auditory capabilities is sparse, the structure of its inner ear suggests that Ankylosaurus was capable of detecting low-frequency sounds. This could have been useful for sensing the movements of large predators or communicating with others of its kind. I find one hypothesis particularly intriguing, that Ankylosaurus may have used its sensory abilities in conjunction with its defensive adaptations. Its acute sense of smell and hearing could have allowed it to detect a predator's approach early enough to position itself defensively, presenting its armored back and tail club as a deterrent. These advanced sensory capabilities underscore just how specialized Ankylosaurus was, perfectly equipped to navigate its dangerous environment. The reign of Ankylosaurus, of course, came to an end along with that of other non-avian dinosaurs during the KT extinction event, approximately 66 million years ago. But its legacy lives on in our understanding of natural design and defense mechanisms. The Cretaceous period was an era of titans. It produced not only the largest terrestrial predator, but also the largest land animal ever known, a true monster mash of epic proportions. While dinosaurs dominated, other species also reached massive sizes, including flying reptiles and marine lizards. Around 82 million years ago in North America, the world witnessed the emergence of Deinosuchus, the largest crocodilian in Earth's history. This colossal creature, whose name translates to terrible crocodile, was discovered in the 1850s when large, distinctive teeth were unearthed in North Carolina. Initially, these teeth were mistaken for those of a pliosaur, a type of marine reptile, leading to considerable confusion among paleontologists. But they quickly realized that this creature was something truly massive and imposing. The sheer size and unique characteristics of the teeth didn't align with known marine reptiles, prompting a deeper investigation. The journey to accurately identify this gigantic predator was significantly advanced by Dr. Joseph Leidy, a leading paleontologist of the 19th century. His meticulous examination and publications played a pivotal role in re-evaluating these remains. Leidy's research corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. The newly proposed classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Deinosuchus hatcheri, in honor of John Bell Hatcher, a distinguished paleontologist. It's almost hard to believe, but some early estimates suggested that adult Deinosuchus could reach almost 50 feet in length, weighing over 10 tons. Even though those numbers were exaggerated, they weren't actually that far from the truth. Unlike many species whose size gets revised downward over time, Deinosuchus has held on to its reputation as a true giant. New discoveries continue to confirm just how immense it really was. There are 3 recognized species of Deinosuchus: hatcheri, rugosus, and riograndensis. Deinosuchus hatcheri, found in North Carolina, was one of the first identified, giving us critical insights into the genus's structure and how it lived. Deinosuchus rugosus, mostly found in Montana, had a more robust build, which might have been an adaptation to different prey or environmental conditions. And then there's Deinosuchus riograndensis, uncovered in Texas. This lineage grew even larger than its eastern relatives. These remains were more plentiful and better preserved, which gave paleontologists a clearer picture of the ecological role and life habits of these giant reptiles. I find it fascinating that paleontologists estimate the average adult Deinosuchus mead between 26 and 33 feet long and weighed between 2.5 and 5 tons. Its body and snout were superficially similar to these modern relatives. But beyond that general resemblance, Deinosuchus was distinct from other crocodilians. It had a unique skull shape that we don't see in any living or extinct genus. The skull of Deinosuchus was exceptionally large, measuring up to 5.6 feet long. That's comparable to the skull of an adult Spinosaurus. And yet, despite its size and robust build, studies have shown that Deinosuchus's bite force was, surprisingly, somewhat modest. A 2002 study reported a bite force of about 18,000 newtons. That's enough to crush bones, but it's relatively weak considering its size, especially when you compare it to the smaller saltwater crocodile, which can exert a bite force of 16,500 newtons. When I look at Deinosuchus fossils, I see that its skull wasn't just massive, it was also highly specialized. The arrangement of its teeth shows a clear adaptation to its predatory lifestyle. It had conical and sharp front teeth for grabbing prey, and blunt, robust rear teeth designed for crushing bones. This unique dental structure allowed Deinosuchus to tackle a wide range of prey, from large dinosaurs to hard-shelled turtles. It was a truly versatile and formidable predator. The bite force of Deinosuchus has been a hot topic for debate and study. In fact, it has one of the widest ranges in estimates for any prehistoric predator. Initial research suggested a bite force of around 18,000 newtons, based on the size and structure of its skull. But a later study challenged that, proposing that Deinosuchus had an astonishingly powerful bite force exceeding 100,000 newtons. That's nearly double that of Tyrannosaurus rex. Dr. Greg Erickson, who led one of the key studies, used advanced biomechanical modeling to simulate Deinosuchus's bite mechanics. His team found that the robust construction of its skull and teeth could have supported such a formidable bite force. With 22 exceptionally strong teeth designed to withstand high forces, and some specifically adapted for crushing large bones, this ancient crocodilian was well equipped to exert tremendous press. The latest evidence seems to be leaning toward the higher end of that estimated range, reinforcing the idea that Deinosuchus really could have had one of the most powerful bites of any known predator. This higher estimate aligns with the physical characteristics of its skull and teeth, suggesting that it was capable of generating extreme biting forces, making it one of the most formidable crocodile forms ever to have existed. The formidable bite force of Deinosuchus, along with its durable and sizable teeth, about the size of a banana, can you imagine, points to its role as a dominant predator of its time. This prehistoric giant was well equipped to tackle the largest prey in its environment. I find myself often pondering the ancient world, and recently, my thoughts have been consumed by Deinosuchus. It's a name that doesn't quite roll off the tongue, but its presence in the late Cretaceous period was truly immense. Bite marks on fossilized tail vertebrae tell a grim story. Duck-billed dinosaurs, like Griosaurus and Chasmosaurus, were clearly on the menu. The danger Deinosuchus posed wasn't limited to just one type of dinosaur. Its sheer size and strength made it a threat to nearly everything around it. Ankylosaurus, Hydrosaurus, even large theropods like Appalachiosaurus, none were entirely safe. I can only imagine the impact it had on the ecosystem, this apex predator shaping the size and distribution of other theropods. It seems no other theropod in the area reached its size, further supporting its role as a top predator. Coprolite analysis, the study of fossilized feces, has given us direct insight into its diet. Dinosaur bones, fish scales, turtle shells. It paints a picture of a truly opportunistic feeder. Dr. Karen Chin, a specialist in this field, emphasizes just how valuable these findings are. It seems Deinosuchus wasn't picky. I imagine Deinosuchus using ambush tactics. Its massive size and crushing bite delivering fatal blows. Much like modern crocodiles, it likely employed a death roll, grabbing its prey and spinning rapidly to incapacitate and dismember it. Reconstructing these hunting methods involves piecing together fossil evidence and drawing parallels with modern crocodilians. Its robust neck muscles and sturdy body all point to this being a highly effective predator. What's fascinating is that Deinosuchus experienced a rather slow growth rate. Growth rings on its osteoderms, those bony plates that served as armor, suggest it took around 35 years to reach full size. But even as juveniles, they were still formidable predators, sporting considerable size and powerful bites. Those osteoderms, by the way, were not just for protection. They also supported its massive body, increasing its load-bearing capacity and allowing it to move efficiently on land. The success of Deinosuchus is clear from its extensive range. Remains have been found throughout the United States and northern Mexico. During its prime, the American continent was divided by the western interior seaway, and Deinosuchus thrived on both sides. It inhabited a variety of environments: estuaries, freshwater lakes, rivers, and possibly even deeper marine waters. Some believe the marine remains might have been displaced after death, but its adaptability is undeniable. Its preference for estuaries, those coastal bodies of brackish water, is particularly interesting. But it also thrived in freshwater lakes and rivers, and potentially even marine environments. Its strong limbs and tail allowed it to navigate both aquatic and terrestrial settings, tolerating varying salinity levels, a testament to its ecological flexibility. If Deinosuchus did venture into deeper waters, it might have encountered other giants, like Tylosaurus, one of the largest mosasaurs. The thought of that interaction, a complex predator-prey dynamic playing out, is truly captivating. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. Herbivores like Anodontosaurus, Griosaurus, Cosmoceratops, and Eutriceratops were all part of its world. Bite marks on their bones are a stark reminder of its predatory behavior. Despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear. Climate changes, sea level fluctuations, competition with emerging predators. These are all potential factors. Its extinction marked the end of an era, but its fossil remains continue to offer invaluable insights into the life and ecosystems of the late Cretaceous period. And then my thoughts drift to another apex predator, one that feels a bit closer to our modern understanding of the animal kingdom. In the world of big cats, the tiger, lion, and jaguar often take center stage. But there was an ancient beast that dwarfed them all, the American lion. This was no ordinary feline. It was the largest to ever walk the earth. DNA analysis has shown that it emerged from an isolated population of cave lions that became trapped south of the North American ice sheets approximately 340,000 years ago. The sheer size of the American lion sets it apart from any feline, living or extinct. On average, these beasts were about 25% larger than today's African lions. Male American lions typically weighed between 774 and 930 pounds, already making them substantially larger than any living big cat. However, the most impressive specimens, discovered in 2012, have been estimated to weigh an astounding 153 pounds, equivalent to the weight of 8 adult humans combined. Even the largest recorded Siberian tigers, which are the biggest living cats today, rarely exceed 660 pounds. The American lion's only real competitor for size was the equally impressive Smilodon populator, which could reach weights of up to 1,040 pounds. What makes the American lion particularly remarkable is that, despite its enormous size, it maintained the agility and speed characteristic of big cats. Conservative estimates suggest it could reach speeds of over 30 mph, faster than any human athlete, and comparable to a charging warthog. This combination of size and speed would have made it an extraordinarily effective predator. The hunting strategy of the American lion likely relied heavily on ambush tactics, a conclusion drawn from both its anatomical features and the hunting behaviors of its modern relatives. Its robust bone structure and powerful muscles would have allowed it to quickly overwhelm large prey, while its long legs provided the burst speed necessary for successful ambush attacks. Fossil evidence provides compelling insights into its hunting capabilities. The discovery of Blue Babe, a remarkably preserved steppe bison in Alaska, bears the unmistakable marks of an American lion attack: deep claw wounds and distinctive bite patterns that match the predator's dentition. Even more telling are the fossils found at sites like Natural Trap Cave in Wyoming, where researchers have uncovered numerous prey species bearing the characteristic damage patterns of American lion predation. What truly set American lions apart from their contemporary rivals wasn't just their size. It was their exceptional adaptability and territorial dominance. Recent studies of fossil deposits across North America have revealed fascinating insights into their social structure and hunting territories. Unlike modern African lions that typically control territories of 100 to 200 square kilometers, evidence suggests that American lions commanded vastly larger ranges, some extending up to 500 square kilometers per pride. This massive territory was a necessity, not a luxury, given their enormous size and corresponding caloric needs. The fossil record tells us an intriguing story of their social dynamics. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller but more efficient. Bone assemblages at key sites suggest groups of 4 to 6 adults working together with devastating effectiveness. Their smaller pride size, combined with their larger individual mass, meant each pride needed to bring down fewer but larger prey animals to sustain themselves. Perhaps most fascinating is the evidence of their den sites discovered in caves across the American West. These sites, particularly those found in the Grand Canyon region, show signs of multi-generational use, some caves bearing marks of occupation spanning thousands of years. The walls of these dens often bear deep scoring marks from claws, a behavior seen in modern big cats, but at a scale that dwarfs anything in the present day. Some of these marks are placed over 3 meters high on cave walls, providing tangible evidence of their incredible reaching height when standing on their hind legs. These locations have yielded another surprising discovery: collections of bones from juvenile American lions of varying ages, suggesting that, like modern lions, they had developed sophisticated parenting strategies. Unlike solitary big cats such as tigers, American lions appear to have invested heavily in cooperative cub rearing, a social adaptation. I've always been struck by the sheer power of nature, especially when I encounter evidence of creatures long gone. This flightless Quetzalcoatlus theory, which emerged around 2010, never really gained much traction. Today, almost all paleontologists agree that it was, in fact, capable of flight, a conclusion supported by a recent discovery. The unearthed bones suggest that Quetzalcoatlus had incredibly light, almost potato chip-like bones, which would have made flight far easier than we might expect. This revelation, however, led researchers to another major question. How did Quetzalcoatlus actually take off, and how did it fly? Many theories have been proposed. Some paleontologists describe the enormous reptile leaping into the air by flapping its wings, or perhaps lurching forward on its wingtips, rather like a vampire bat. In other scenarios, it may have crouched low before launching itself as much as 8 feet into the air, giving it enough room to spread its wings and take flight. Its secret weapon, it seems, was those strong hind legs, providing the massive push required to jump skyward. One study even suggested that Quetzalcoatlus was a remarkable flyer, engaging in brief bursts of powered flight before gliding, reaching a top speed of 130 kilometers per hour, about 80 miles per hour. It could perhaps sustain this for 7 to 10 days, giving it an extraordinary range. Despite being relatively small in relation to its bulk, Quetzalcoatlus's torso was extremely dense, packed with massive muscles. It's thought that one of these giants could take off with a single leap and maintain its altitude with just a few flaps. Once airborne, they could probably fly non-stop for 16,000 kilometers, flapping infrequently to maintain altitude and course. Its short wings were made of tightly packed muscle fibers, called actinoprils, which end both flexibility and strength, allowing for precise adjustments in the air. The extraordinary flight techniques of Quetzalcoatlus even inspired a Johnson Wax-sponsored mission to construct a model flying machine to test flight simulations. The model, about the size of Quetzalcoatlus lawsoni, used a basic computer as an autopilot and successfully demonstrated the effectiveness of these flight dynamics, soaring and flapping its wings through the air. Interestingly, Quetzalcoatlus and other Azhdarchids have hind limb proportions more similar to modern running ungulate mammals than to their smaller pterosaur cousins, suggesting they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds when on the ground like other pterosaurs. All of this led scientists to further investigate the lifestyle and feeding habits of Quetzalcoatlus. It's widely accepted now that this flying giant was a carnivore, but precisely what it ate remains a subject of speculation. Douglas Lawson, the scientist who first discovered Quetzalcoatlus, suggested it scavenged on the carcasses of Titanosaur sauropods, much like a marabou stork. On the contrary, their anatomy is similar to modern storks, suggesting that they most likely pursued and hunted small animals on land. For a time, Quetzalcoatlus and its relatives were seen as giant vultures, scavenging the carcasses of dinosaurs and other dead animals. But with time and scientific advancements, we are starting to learn more about the habitat of this unique creature that once ruled the skies of the late Cretaceous Maastrichtian age of North America. It seems most likely that Quetzalcoatlus lived in a variety of settings during the late Cretaceous period, including both coastal regions and inland plains. These enormous landscapes supplied the thought of encountering Quetzalcoatlus, these colossal creatures, truly makes me grateful to live in a time beyond their reign. Imagine skies once dominated by such giants. Quetzalcoatlus northropi, it seems, was most likely a solitary hunter, freely roaming the inlands. In contrast, Lawson may have lived in swarms within alkaline lakes, suggesting they were more sociable, waiting birds. The environment offered these creatures various options for hunting, nesting, and roosting. And it wasn't alone. Fossils suggest that creatures resembling the renowned Tyrannosaurus and Torosaurus might have coexisted with Quetzalcoatlus, though conclusive studies are still needed. Alongside the iconic Alamosaurus, Quetzalcoatlus may have crossed paths with other herbivorous giants, and even fearless predators like the mighty T-Rex, Dromaeosaurus, Triceratops, Albertosaurus, Edmontosaurus, and Dakotaraptor. In the skies, Quetzalcoatlus likely shared space with other pterosaurs, such as Pteranodon and Nyctosaurus, coexisting within those extinct ecosystems.